In this video, we're going to look at some of the properties of the different kind of triangles that we learned about previously. The first one, if you recall, is an isosceles triangle, which means that two of its sides are equal. So AB equals AC, which we mark, if you recall, by drawing a similar mark on both sides. And the opposite angles are equal, which we again denote on a diagram using that symbol. Now, if you take this part A, this point A, and you draw an altitude. Now, altitude is another word for height or a vertical line or something that has 90 degrees. And when this happens, it bisects, meaning divides into two parts equally the base, meaning if this point is T, then you have that CD equals DB and the vertex angle, meaning if you look at the angle CAD, it is going to equal the angle DAB. Now, equilateral triangle, that's when all three sides are equal and all three angles are equal. And they are equal to 60 degrees. Think about why this is true. And the result says, if I draw an altitude, then it bisects the side and the vertex angle. But not just that, this is any altitude. So the difference being here is this is the altitude to the base, meaning it is the altitude corresponding like in between the two sides that are equal. Whereas in an equilateral triangle, even if I drew an altitude here, these are going to be equal and this angle is going to be equal. And if I draw an altitude from this third point, again, these are going to be equal and these angles are going to be equal. So it's more powerful result in case of an equilateral triangle. Example, let's say in this problem, you have to determine the length of the side A and angle 1, and everything else is given to you. The first thing to observe here is that these are equal, so it is an isosceles triangle, which means angle 1 equals 38 degrees 46 minutes because opposite angles, or these are angles of an isosceles triangle. The next thing we know is this is an altitude. Why is it an altitude? Because there is 90 degrees, which means A is going to be exactly half of this total length, which is 4.6. The second example, find angle 1, angle side D and E. Now, the fact that these are 60 degrees means that this whole angle is also 60 degrees, which means it's an equilateral triangle. That means D has to equal 8 foot 3 inch. And E is going to be half of that because this is a altitude again. And what an altitude does is bisects the side. So it's 8 foot 3 inches divided by 2, which we can write as 4 feet 1.5 inches. But an altitude also divides the angle, which means angle 1 is half of 60 degrees, so it is 30 degrees. And again, I'm going to box these values as the ones that have been asked to be found. That's it for this video. We're going to look at another special triangle called the right triangle in the next video.